In this video, we're going to learn about Roman numerals, okay? So far, in terms of writing ionic compounds, we have been using everything in columns 1 and 2, and then over here in 3 through 7, okay? And then our polyatomics. But so far, we've just sort of ignored this whole transition metal section, okay? So now we're going to address what we need to do when we have transition metals. So iron is a transition metal, okay? So I'm going to give you an example of a compound, or a couple of compounds that iron forms, okay? So iron can combine with oxygen like this, or it can combine with oxygen like this, okay? These are two very different compounds, okay? They behave differently, they have different properties, okay? Now, according to our traditional naming, so the way that we've learned to name simple ionic compounds, we would name the cation first, so we would say iron, and then we'd have the end would be oxide. And then here, again, I would have iron oxide. Okay? So if we were just look at the name, we wouldn't know that there was a difference that we were talking about this iron oxide or this iron oxide. We also wouldn't have any idea how to write the formula, because if we looked at our reference tables, iron isn't in a group where we know the charge. The reason is because transition metals can have variable charges. Sometimes they can be +1s, sometimes they can be +2, sometimes they can be +3. They will lose different electrons or numbers of electrons in different instances. Okay? So how do we know what their charge is, and then how do we indicate that in the name, right? So if we look at the periodic table, oxygen is in column 6, so we know that it is a 2-, okay? Ionic compounds are electrically neutral, so if this guy is a 2- and I only need one iron to balance him out, then he must be a 2+. So in order to indicate what charge iron has in the name, I use a Roman numeral. So I put 2. Okay? So iron 2 oxide means iron with a +2 charge with oxygen. Okay? So Roman numerals in a name indicate the charge of a transition metal ion. A transition metal ion. Okay, so if we look at this example here, let's try and figure out what its charge is. So again, oxygen is a 2-. So in order to balance out the 3 oxygens that I have here, then this guy must be 3+. And again, we can kind of do this like reverse crisscross, right? We can bring the 3 up here and the 2 up here. So this is actually iron 3 oxide. Okay? Now, let's just do another example where we have a name, and then we'll go to a formula from it. Okay? So I'm going to do one that actually combines both polyatomics and Roman numerals. So let's do copper 2 sulfate. Okay? Copper 2 sulfate would be copper with a 2+ charge. Sulfate is SO4. It also has a 2, but it is a 2- charge. So if we were to crisscross down, okay, we would have CuSO4. Okay? Remember that we reduce to the lowest whole number ratio, so if we have 2 coppers for every 2 sulfurs, that's the same thing, or sulfates, that's the same thing as saying 1 copper for every 1 sulfate. Okay? Now, the only exception to the Roman numeral rule are zinc and silver. Zinc and silver will always have the same charge when they become an ion. One of them is a +1 and the other is a +2. Silver, let me just zoom in here so you can see them a little bit closer. Silver is a +1 and zinc is always a +2. So you won't see Roman numerals when we have either silver or zinc. Okay. Now, how I remember which one is a +1 and a +2, I remember that a Z always looks like a 2 to me, so I know that zinc is the one that is a +2. And we will be practicing with Roman numerals a lot more in class.